All right, welcome to This Explainer. Today, we're going to completely reframe something you probably learned about way back in grade school. You see, the agricultural revolution wasn't just about, learning how to farm. It was actually humanity's very first massive foray into systems engineering. We kind of tend to think of ancient history as this simple, primitive time, but the reality? The literal foundation of our entire modern world was engineered from the ground up, starting millennia ago. Okay, so let's dive right into this bizarre but totally true question. How on earth did floppy-eared wolves and mutant wheat lay the foundation for modern capitalism? I know. It sounds like the setup to a weird joke, but it's the literal truth. Every single modern system we rely on today, from global finance to the literal device you're watching this on right now, started with this crazy, cascading chain reaction of human engineering roughly 12,000 years ago. So let's trace that chain reaction together, step by step. So, moving right into part one, the bioengineering of life. Our giant domino effect really kicks off in the early Holocene epoch. This is when humans made a monumental shift from just foraging for whatever they could find to actively bioengineering the natural world around them. And they did this through artificial selection. Basically, early farmers deliberately chose what lived and reproduced. They were preferentially propagating the plants and animals that had the traits they actually wanted. Slowly but surely, we were turning wild, untamed ecosystems into human-dependent agro-ecosystems. And honestly, nothing illustrates this change better than what we did in the plant kingdom. On the one hand, you've got wild wheat, right? It easily shatters and just scatters its seeds in the wind to reproduce. But on the other hand, we have the wheat that we engineered. We selectively bred this mutant variation with a super tough stem called the rachis that basically keeps the grain tightly attached so it's way easier for us to harvest. Think about that for a second. We literally engineered a plant to become entirely reliant on us to reproduce, just to make our harvest more efficient. Pretty wild. But artificial selection didn't stop at plants. It profoundly affected animals too. When early humans started domesticating wolves, they were mostly just selecting for reduced aggression, right? They wanted docile animals they could actually control. But breeding for docility triggered this genuinely bizarre biological phenomenon called domestication syndrome. It quite literally altered their physical appearance, resulting in the shorter snouts and the cute flop-eared dogs we know and love today. This deep biological integration was really our very first act of environmental engineering. Which brings us to part two, mastering the flow. So we successfully bioengineered our food, which is great, but that success permanently tied us down to specific plots of land. So how do you survive when your specific piece of land just doesn't get enough rain? Well, enter early hydraulic engineering. In incredibly arid regions like southern Mesopotamia, you simply couldn't sit around waiting for a storm. Solving this massive water problem required early applied physics and fluid dynamics. Engineers had to calculate really precise gravity gradients. I mean, if the water flowed too fast, it eroded the canals. If it flowed too slow, it stagnated and filled with sediment. They literally had to go in and re-sculpt the earth. But what happens when you need to push water where it naturally really doesn't want to go? You invent simple machines. We developed the counterweighted shaduf to lift water, the famous Archimedean screw, and in places like the Iranian plateau, this ingenious underground kanat system to move water from mountain aquifers while keeping it from evaporating in the blazing sun. Now, building and maintaining these devices wasn't a solo job. It required highly coordinated labor, which ultimately led to the birth of large-scale hydraulic civilizations, where your political power was directly tied to your control over the water supply. All right, moving along to part three, the power of surplus. Mastering water and crops solved the immediate how do we not starve problem, but it accidentally created a massive new one. We suddenly had way more calories than we could possibly eat before they spoiled, and this birthed the entire concept of surplus production. When you generate resources far beyond your immediate survival needs, you aren't just storing extra food, you are essentially storing labor. Early cities like Uruk built these massive, centralized mud brick granaries to protect their grain, and in doing so, they turned excess food into stored power and immense economic potential. And because not everyone had to spend their days breaking their backs farming anymore, this surplus basically birthed the modern economy. It allowed for true labor specialization. Suddenly you have full-time artisans, administrators, and priests, and that catalyzed incredible leaps in metallurgy and pottery. But crucially, because we were now trading these specialized goods for stored grain, we were practically forced to invent mathematical systems and numerical abstraction just to keep track of who owned what. For the very first time, value became detached from physical presence. Which perfectly sets up part four,
Early information technology.
Okay, imagine for a second you're a newly minted administrator in one of these ancient cities. You've got plenty of food, complex economies, labor specialization, it's booming. But how on earth does a fragile, squishy human brain keep track of thousands of bushels of wheat and complex tax debts across thousands of citizens? Spoiler alert, it can't. The answer to that cognitive bottleneck was humanity's ultimate IT upgrade, writing. We figured out how to practice externalized cognition, taking ephemeral spoken language and turning it into tangible, durable symbols. It was a literal memory augmenting tech that kept our growing societies from just collapsing under their own administrative weight. And what's absolutely fascinating is that across different civilizations, humans just used whatever diverse mediums they had lying around to solve this massive data storage problem. Around 3200 BCE, Mesopotamians were pressing cuneiform into wet clay. Shortly after that, Egyptians started painting hieroglyphics onto papyrus. Later on, during the Shang dynasty in China, logographs were being carved directly into oracle bones. But regardless of the medium they used, the end goal was exactly the same: detach information from the limitations of the human mind, allowing knowledge to actually survive across time and space. By creating these permanent records, writing completely transformed the state. It was a total game changer. We could now write down and actually enforce standardized legal codes over vast distances. We recorded complex mathematical tables and logged precise astronomical observations so we could predict seasonal flood cycles. This ancient IT revolution drastically accelerated the pace of our scientific and technological evolution, making human civilization entirely self-reflective and cumulative for the very first time in history. And that brings us to our final act, Part 5, the urban crucible. All right, let's pull all these threads together. We now have bioengineered food, hydraulic systems, massive economic surplus, and IT systems to manage it all. This exact cocktail set the stage for the most explosive demographic shift in human history, as food reliability caused mortality rates to drop and fertility to just absolutely skyrocket. We made a massive trade. We completely traded our history of nomadic egalitarianism, living in scattered hamlets focused on immediate consumption, for organized hierarchy. We organized ourselves into incredibly dense, highly structured urban centers defined by centralized authority. And this created an unstoppable high-speed feedback loop. Think about it. An agrarian surplus causes a population boom. Those newly dense populations suddenly demand incredibly complex infrastructure just to survive. And managing that massive infrastructure, well, that incentivizes even more bureaucratic and technological innovation. These early cities basically became giant buzzing incubators for human progress, literally forcing the standardization of laws, measurement, and currency just to keep the whole shebang from falling apart. The source material actually sums up this incredible transition perfectly, noting that in this urban crucible, humanity moved from simply surviving on the Earth to systematically engineering a civilization that would eventually reach for the stars. Every single one of these interconnected systems we've explored today provided the exact structural scaffolding required to build the modern empires and the complex global trade networks we're living in right now. Which really brings us to a final, kind of provocative thought. We've spent the last 10,000 years tirelessly engineering the Earth to suit our needs. But when you step back and look at this deeply interconnected feedback loop, how has the Earth engineered us? It is truly mind-blowing to think that every massive, complex system running your daily life today is really just an upgraded version of Neolithic software. It definitely leaves you wondering, how is this relentless, driving pursuit of mastery going to shape the very next phase of our own human evolution? Well, thanks so much for exploring this with me today. Keep asking those big questions, and I'll catch you in the next explainer.